Hey guys, today we're going to solve a problem from LeetCode, and the reason this blog is in English is because most of the time you're going to solve all these problems in English when you're coding on a real interview. So I propose this problem in the dynamic programming section of the website, and also this could be solved using recursion, but some requirements of this specific problem doesn't allow us to use a lot of memory that recursion will use. Uh, so we need to solve this with dynamic programming. So the problem says that we are climbing a staircase and it takes n steps to reach the top. So each time we can climb either one step or two steps, and we need to count how many distinct ways we can climb to the top. So the input is that we have an n positive integer, that it's the number of steps, I mean, will be the number of steps or stairs that we need to climb. And for example, in this case, we have four steps, and we can have two, we can have one, we can have three, or we can have n. So for example, in this case says two, and in this case we have only two ways to solve this. I mean, two ways to climb to the top. And why is that possible? Okay, so well, basically, a better way to understand this is to think more about the number of paths that you can follow. So, for example, in the case of two, we can climb from uh, from the from the floor to the first step, and we can climb. Okay, sorry, and then from here we can climb up to here. That will be one way to arrive here. And if we go from the very beginning or of the floor to here, then we will have two ways or two paths to arrive here. In the case of the one, it's only a single way to arrive here because we cannot jump two steps to climb to the first step. And then we have another test case that is the input tree, where we have three ways to arrive to the top. So as I told you, this is more about not thinking about how many ways. I think that you need to think about the number of paths. So until here we have two ways. So if we want to climb to this third place, we can again just climb up from here, and we have one way to arrive here, and we can climb up from the first step. So that will be a second one, but that is not the correct result. I mean, if we say, okay, it's three and it's okay, but it's not that simple, because you need to understand that mm, that if you climb from here up to here, it's one way to do it entirely, okay? And if you just grab all this, it's another way. So that's a path. We don't need to add any extra thing. So in this case, we will have 1 plus and 2 plus 1, that are the rest of the previous steps. This will be number 3. This is the sum. So now how many ways I have to climb up to here? Okay. So if we follow the previous thing that we have done up to here, We can go again we can climb up from this step. Sorry, this 4 is not need to be there. We can climb up from here, and we can climb up from here. So again, we have 2 ways to arrive there, but this number is telling us that we have 3 ways to climb up to here, up to the number 3. And if we consider this single jump as a single identity, it means that there are also three ways to climb up to the 4th step, okay? So in this case, we have the option to climb up. Okay, this tree comes up from climbing from 1 to 3 or climbing from 0 to 1. Sorry, the tree comes up from climbing from 0 to 1 and then from 1 to 2 and then just climbing from 2 to 3. That it's one path, okay? So 1, then 2, then 3. This is one path. And then we can climb up from 1 up to 3, and that will be a second path. And if we climb from 0 to 2 and then to 3, sorry, that will be the third path. So if we are on the third path and we just move to another step, it will be part of the same path. So this will be the 4, and we can go to 4, and it's again the same path. But also we can climb up from the 2, and it's applied the same logic to it. So basically, it's some kind of Fibonacci sequence. If you see the pattern there, it's some kind of Fibonacci sequence. So if we consider this, we can simply sum what we have here with what we have here, that it's 3 plus 2, and this is equal to 5. Okay, so how we code this? So as we know, this is a dynamic programming problem. So first we need to declare our dynamic structure. So it would be DP, or dynamic programming, of size n. So if the and as we know, our base cases is to know how many steps, how many ways we have to arrive to the first 2 elements. Okay, so you can say if n it's greater than 1, sorry, it's greater or equal to 1, we can say that dp at 0 it's equal to 1. Okay, and if n it's greater or equal to 2, we can say that dp at 1 it's equal to 2. Okay, so we have now our 2 base cases, and then we simply need to return the result at the end of the array. That will be the last step here. But in order to complete this, we simply need to iterate all the rest of the array. So int I will be equal to 2, because we have now here covered the rest of the cases. So we need to start from the third index, or index 2. E should be less than n and I plus plus. Sorry. And then how we calculate our current element? Well, that's quite simple. We simply say that dp at I will be equal to dp at I minus 1 plus dp at I minus 2. And that's it. If I click submit here, it's an accepted. So thank you for watching this video.